Hi guys, welcome back. In this lecture we will study relative velocity in two direction. So guys, first of all consider a fixed frame of reference F. Now we will consider a moving frame of reference F dash, which is moving. Okay. So the position vector of this moving frame of reference F dash with respect to this fixed frame of reference is like this: R vector F dash oblique F. Now consider a particle P which is also moving. Okay. Now the position vector of this particle P with respect to this fixed frame of reference is like this. So this is R vector P oblique F. Okay. Now the position vector of this particle P with respect to this moving frame of reference F dash is this one. So this is R vector P oblique F dash. Okay. Now from the triangle law of vector addition, the sum of these two vectors is nothing but this vector. So the sum of position vector of particle P with respect to moving frame of reference plus the position vector of moving frame of reference with fixed frame of reference is nothing but this one. Okay. So the position vector of particle P with respect to fixed frame of reference is equal to position vector of particle P with respect to moving frame of reference plus position vector of moving frame of reference with respect to fixed frame of reference F. Okay. Now integrate this whole equation with respect to t. We will get d r vector P oblique F by dt is equal to d r vector P oblique F dash by dt plus d r vector F dash oblique F upon dt. So earlier we have seen the differentiation of position vector with respect to time will give us velocity. So this would be velocity of particle P with respect to fixed frame of reference is equal to velocity of particle P with reference to moving frame of reference plus velocity of moving frame of reference with respect to fixed frame of reference. Okay. So this is the result. Okay. So if we consider fixed frame of reference F to be ground denoted by G and moving frame of reference F dash to be train. Okay. Let us consider this moving frame of reference F dash to be a train. Okay. Denoted by T. So now this equation will become velocity of particle P with respect to ground is equal to velocity of particle P with respect to train plus velocity of train with respect to ground. Okay. Now rearranging this equation, it will looks like velocity of particle P with respect to train is equal to velocity of particle P with respect to ground minus velocity of train with respect to ground. Okay. So you can see that velocity of particle P with respect to train is nothing but velocity of particle P with respect to ground minus velocity of train with respect to ground. Okay. So again, if we consider two moving frame of reference, like A is one moving frame of reference with respect to ground and another is second moving frame of reference with respect to ground. Now if we find out the relative velocity between these two moving frame of reference, so the relative velocity would become like this: velocity of A with respect to B is nothing but velocity of A with respect to ground minus velocity of B with respect to ground. Okay,